Adding data for logic solvers is very similar to the way that you would create a new sensor. So I'm here on the logic solvers page. I'm just going to go ahead and click add new logic solver, and the form that comes up should be very familiar because it's nearly identical to what you saw for sensors. In fact, it even has a little bit less information because for logic solvers you don't have interface devices. So the same type of information in terms of selecting a type, adding tag numbers and descriptions, adding test intervals and voting arrangements is all available, and then all of the same contributions, the same 5 contributions that you saw for sensors, you're also going to see for logic solvers. So it's simply a matter of filling out the form the same way as was described for the sensors. When entering data for PLC-based logic solver subsystems, there are 3 different ways to enter the data that you should be familiar with. Now remember, Vertigo performs calculations of PFD and spurious trip rate if you enter in component failure data. So the 3 options that you have for performing PLC calculations are black box model, equivalent 1 out of 1, and individual components. Let me break those down. The first one is highly recommended, and that is the black box model. So what you would do is you would go to your equipment vendor and have them perform calculations for their PLC system. This is actually what the equipment vendors prefer because their systems are so complex and hard to perform calculations on using standard tools. So once you receive the black box model data, you set up a black box model as described earlier, no problem. The second one is going to be the component approach. And PLC systems have input cards, they have output cards, and they have CPUs. So what you would need to do is you would need to include data for the input cards as a sensor interface, data for the output cards as a final element interface, and then perform calculations on the CPU as the logic solver itself. The final approach is what we call equivalent 1 out of 1. And for equivalent 1 out of 1, you'll see equivalent 1 out of 1 in the Kenexis databases for generic components, for instance. What we've done is we've analyzed an entire system, sensors, or input cards, output cards, power supplies, CPUs, in a all series of complex voting arrangements, and then calculated at PFD and a spurious trip rate as though it were a black box model. We then took the PFD and spurious trip rate and reverse engineered what would the failure rate, safe failure fraction, and diagnostic coverages need to be for a 1 out of 1 system in order to achieve that same probability of failure on demand and spurious trip rate. So using the equivalent 1 out of 1, you have numbers that the Vertigo calculation engine can use to perform calculations and allow you to do things like change the test interval, which it's not so easy to do when you have a black box model. So remember the complexities of entering in failure data and setting up logic solvers because it can be done different ways, and you want to make sure, for instance, that if you're using equivalent 1 out of 1 data, that you don't put a 2 out of 3 voting arrangement in, because that 2 out of 3 voting is already baked into that equivalent 1 out of 1 calculation methodology.